Hi, I think we can get things moving, and folks will be joining once the session begins, right? I just want to say a few things first. First, this one, Emerald, it's a session that's going to be recorded, right? And for folks that could not join us today, they can see it offline, right? First of all, I wanna thank you. Thanks everyone for joining and to our last the last webinar for the fiscal year, right? For the emerging technology COP. But today we're going to talk to our friends from IDenTV, Emerald and Dr. Mark. They're going to present us their solution for applied AI and a whole bunch of more things, right? For this session, as the previous one, we have all the questions this time made in the Slack channel, right? So we're going to create a thread specific for this session. Emerald and Mark won't be able to see it, but we can replicate the question for you guys. The idea is to have the history of questions there for those that are, in other time zones, they can see all the questions and get the context for what happened today, right? So please ask us your questions there. I'm going to create a thread. And with no further ado, I want to introduce you guys, Emerald and Dr. Mark. First of all, thanks for presenting to us today. Could you guys please introduce yourselves and explain what we're going to see today?
Yes, absolutely. So my name is Amr Shihada. I'm the co-founder and chief operating officer at IDenTV. So what you'll be seeing today is a solution that basically analyzes big data and allows you to make it interactive using various a library of AI models and engines, all operating in real time and integrated with the Oracle Cloud and Oracle Cloud services. And I'll let Mark give you a little bit of background on himself as well.
Hey, very nice to meet everybody. So yeah, just as Amro said, we work primarily in the AI space. We focus a lot on video technologies. So kind of our goal as a company really is to automatically extract as much information as possible from video content, be it in the media space, in the security space, in the government sectors, whatever it might be. Just at a personal level, I head up the teams doing most of the R&D at IDenTV, but pleasure to chat to everybody.
And thank you all for your time, and we really appreciate it. And please don't hesitate to ask any questions or tell us to slow down or speed up. We're very much thankful to have this opportunity. So to get things started, as you guys all know by now, we've certainly have eclipsed the number that you see on the screen with over 80% of all global IP video traffic will be internet traffic will be video by 2022. We've eclipsed that number due to unfortunate circumstances, but this has brought a lot of issues to the forefront. Current methods are costly, they're expensive, they're manual, they're antiquated, and they cannot scale to real-time environments. Where does that leave things vulnerable? That leaves things in a reactive or forensic analysis process. So you cannot be proactive, you cannot leverage automation, you cannot augment your workforce, and that provides you with very little ways to interact with your big data, whether it's video or multimedia data. So what IDenTV does is we're a video-centric startup. We were born in defense here in the U.S., working with the Department of Defense, and we've really focused on extracting contextual metadata from all sorts of different file types and content types. The solutions and industries we touch, as Mark mentioned, range from defense and security to media to smart city applications and retail analytics even. So we are an Oracle startup. We started when the program was still called Scale Up. So we've been a close partner and close team with Oracle since the Gen 1 cloud just got launched. So what we see a lot of really, really good synergies in terms of the ease of use of both solutions, the leveraging of the HPC for large scale computing and the AI and ML models we have, as well as providing a platform for new model customization in much faster times, which allow, for great advantages, but also showcasing, the capabilities of pairing unstructured data with structured data in the ADW offering as well. And then tying back to the ease of use with the Oracle Analytics Cloud, being able to pass this unstructured data to a system that can then visualize intelligently and provide these actionable analytics on a macro level or on a micro level, allow people to transform their big data into real-time analytics, and they're all actionable. All of this has been designed to basically for non-technical operators, so you don't need a data science team. You don't need to invest in building this infrastructure yourself. It can easily run on the cloud or on premise. So the solution itself is called the Video Juicer. And we call it the Video Juicer because we squeeze all of the contextual metadata we can from video, whether that's using computer vision, and you can see a sample of the various different classifiers or engines to your left that we've built, along with, so the platform can ingest multiple file types, whether it's direct from camera, and we're pushing towards the edge more and more, or it can be a large petabytes of video in an archive context, and we process that data. We extract metadata in real time, regardless, and we make it immediately searchable at scale. We do this in it's multimodal and a multi-tenant user interface. So you can log in into the web interface and access this technology, or you can use our robust APIs and integrate it into existing video management systems, media asset management systems, digital asset management systems, and beyond. So some of the technology outside of computer vision that under the hood is our speech recognition, our automated speech recognition. We cover 16 plus languages, and with the different dialects, it is over 35 different dialects and languages. It processes in real time or batch, and this allows us to align and extract even more metadata from the content. This applies in, media monitoring, broadcast, or, digital media, user-generated content, telephony, or even for intelligence and defense purposes as well. So what this really provides us is a multilingual tool to not only analyze the images, but also the audio as well. From that, a transcription is created. And what we can provide then is a method to translate that transcription from the source language to a target language. This covers 40 different languages. Again, it is applicable in media entertainment, government, but also in different sectors around the world. And one thing that's very unique to IDenTV's offering is our intelligent line segmentation for the broadcast media and large archival or large big video data situations, where this allows us to align all of the metadata and allow you to really search and search across multilingual content. But also it allows you to kind of put together content and regionalize it for a specific location. And we'll get into that more as we dive into the use cases. So what does this mean? So if you think about it at a very high level, we are what I like to say is a reverse water filter. So instead of removing toxins or removing things from a stream, we actually enrich the stream with content, whether it's coming from 22,000 feet from a drone, or it's coming from a person's mobile or desktop computer. We apply the proper image and video classifiers, the appropriate multilingual audio classifiers, and we distill it down to text, where we have NLP, natural language processing, that allows us to extract topics, entities, and different types of contextual metadata. What does that do? That allows us to provide scalable and actionable insights and really provide an evolving set of solutions that can be on-premise or on the cloud or in a hybrid deployment to allow people to search, interact, and transform big data from a cost center into a revenue generator or a monetizable solution. So why Oracle and IDenTV? So outside of the obvious savings that can be provided to the customers, we can, since we were born in defense, we've had to train very many niche classifiers or niche models. So with the HPC that Oracle provides, we can actually provide these models at 2x the speed, and that relates to cost savings, but it also relates to improved performance. So what I mean by that is that we work with the customer to not only onboard them for the initial part, but also to provide them iterative creation of these models. And then we also provide tools that allow them to augment our existing models or create their own existing models, all running on the cloud or on premise, and integrated with services that really highlight both companies' capabilities. I think one of the most key takeaways that we should have here is the ease of use between the two solutions and the synergetic qualities of both. So not only leveraging the GPU processing, but the privacy and security that already is inherent with the OCI, as well as the autonomous database to tie the structured and unstructured database or data. And then, of course, the other OCI services that allow us to touch so many different industries. So moving forward, we'll jump right into a use case. So working with the media entertainment industry, what we call this use case, and it can be applied for real-time video, or it can be applied for pre-processed video, video on demand, things of that nature. We call it smart archiving. And what we do here is we take it can be centralized or decentralized, but at the point of ingest, we transform the data from essentially just going into the archive and receiving a file name and maybe having some description or title. But we take that and we enrich it with metadata, and it's all time coded down to the frame level. And what that allows for is intelligently to intelligently search and curate and retrieve content based on its contextual metadata. This is done by very simple text queries or advanced text queries as well, using Elasticsearch. You can also filter by specific engines, timeframes, labels, and basically extract the exact content you need in real time. So I'll just walk you through a quick video here on how that might look in certain situations. So this applies to the broadcast media and beyond. So here, what our system does is it clusters alike faces. So this is a great tool and demonstrates the custom model training. So essentially, it takes these clusters and it applies them and assigns them a unique ID. And I'll dive a little bit deeper in this and later in the call. But this provides the user the capability to see the clustered faces, see what's going into the model and going to be augmenting the model, allowing you to regionalize it globally and language agnostic, and customize it on top of a facial recognition model that already has 120,000 unique faces and growing. So that provides you a great advantage there in reducing costs and labor. We also do brand recognition and brand tracking. So this allows for advanced analytics and measurement of ROI that previously had been unattainable in the past. This also allows you to track and have content intelligence, where you can attribute different measurements of ROI, such as static brand sponsorships. So you can see here we're taking the video analytics and possibly a multi-channel marketing campaign here, and we're able to tie it in with the data there, and say this sponsor is on the screen for X amount of time, and that translates to dollars per second or viewerships per second. And then you can see effectively where the best sponsorship placements are, where the best location for your brand and logo to appear is, how often is it appearing, how often is it being mentioned. And this, I ask you to put your creative hats on and think of yourself as the producers of The Bachelor here, where you can see that not only using the computer vision, but using the automated speech recognition and NLP, you can search for named entities. And you can see searching for a character like Cassie Randolph, who's relatively unknown prior to the show. During the show, she became the fan favorite. Unfortunately, she was not going to win. But as the producer, you know this. So what do? You create more engaging content. So you can search your repository of video and find clips of Cassie Randolph happy with The Bachelor. And from a process that might have taken a week previously, it might take a couple of hours now, integrated with the digital media asset management systems. Then you can automatically export this metadata via the APIs or via JSON file or CSV even as well, and make it more actionable and more intelligible and engaging to the customers, thus increasing your opportunities to add ad dollars or monetize that content more effectively, as well as target specific audience and segments. Another factor we bring to the table is sentiment and trend analysis. Oh, sorry about that. Sentiment and trend analysis. So the sentiment and trend analysis allows us to really provide what we call content intelligence. And you'll see that in a very good example. But we monitor live streams, digital video, tweets, and articles. And you can search, specific events. And here, a great use case that I like to use is Nike. So Nike had an incident last year where a shoe exploded off of one of the best basketball players in college and nearly hurt and ended his career. So you can see here their sentiment was very high, and you can see it drop here. Had Nike been able to quickly identify this as an incident, maybe they would not have led to a $1.3 billion reduction in their market cap due to their inability to change their messaging from we are, providing the most lightweight, space age, new age shoes and athletic technology to, hey, we're Nike, we've been doing this for 60 years, we're trusted by the entire community. So being able to understand and shape that message in real time is something that content providers don't have. And what you're seeing here is the combination of all the technologies in play. So you're seeing the computer vision identify the faces, you're seeing the transcripts created in a source language, you're seeing the transcripts created in a target language. You can see the different named entities highlighted and linking out to third-party data to provide you more information. So this can be used in connected TV. This can be used for content production. This can be used for content distribution and measurement of kind of resonance or how effective clips are. But also these closed captions that we're creating, this transcription we're creating, they're FCC quality closed captions. So you can export an SRT file and actually have subtitles or closed captions in all these various languages. So it really provides you a tool, again, as we mentioned, not only to understand your data, but also to monetize it. And so you can see here, this is running on the news media side of things. And later we'll get into sports as well. But you can see you can track an individual, you can track a country, you can track all sorts of different topics and extract real intelligence from that and decision support tools. So kind of moving on from there. And of course, as you can see, you jump right to that portion in the clip or from your giant repository of video, easily searchable. So as I mentioned, I would be diving into kind of explaining how we differentiate. And we differentiate by providing not only off-the-shelf library of classifiers and engines, but we provide the capabilities for a non-technical user to easily search and index new faces, brands, or even create new engines themselves. So here what I did was I pulled the video off of Karan Bhatta. I'm not sure if you guys are all familiar with Kicking It with Karan, but I pulled a video off his YouTube channel. And what I did was I uploaded that video. And what it does is it creates unique IDs, as you saw previously, and it assigns a distance score. So the lower the score, the better. And what I did was I took a screenshot of this gentleman's face here. I did a reverse image search, and it gave me all the matches with the best matches here. And the lowest matches obviously at the bottom of the screen, but you can see the file is uploaded. I've entered his name, and basically in a few clicks, I have him labeled into the system. And all of these images basically go from a unique ID to a index face in the model itself. And you'll see here as I upload the clip to be processed for recognition, it's identifying both Karan, and you'll see it identify Paresh Kahara. So this is all done without writing a single line of code on the user's end. Or using the APIs, it can get more complex, of course. But this allows for a more lightweight method to augment models, augment your workforce, augment customers' workforce, and really leverage AI and kind of democratize it to reach the specific KPIs needed for that industry. Another example here is something we just recently did with RAI, a large Italian broadcaster in Italy. So here they asked for logo recognition, and you can see the videos here. Of course, the JSON doesn't bounce around. This is from our proprietary video player. So you can see here, it's not only recognizing the logos in the background, but it's also like recognizing the logos in a small kind of on the jersey, on the even on the helmet you'll see shortly, and it's able to provide these analytics to these big sponsors who need to understand where their brand's being presented, how it's being presented, how much screen time it's getting, who it's reaching, and how to further monetize on that. So as you see here, once we move away from this, you can actually see here it's getting the Kaspersky logo that's even just on the side of the helmet. Moving forward, kind of another differentiator we provide is our capability to actually analyze hundreds, if not thousands of faces, given the video resolution is there in real time. So you can see here it's grabbing the faces, assigning the ethnicity, the gender, and giving an age estimation here. So you can see here it's Hispanic/white male in his early 20s. And that provides more contextual metadata, whether it's on the security side, the consumer behavior analytics side, or the media and entertainment side. This is a tool, if you can see the bottom bar, that detects scene changes. So this provides context in the post-production workflow that allows you to address scenes that are more action, that have more action and events, or basically segment your content based on the data in it. So this shot might say, Leclerc hugging his father, or interview with Charles Leclerc, or including the logos, brands, and et cetera, et cetera. One thing that we're really proud of and excited about is our video optical character recognition. So optical character recognition in general is very, very difficult when you move it to the video space, because video causes distortion. So these regular fonts that are normally easily recognized are not. So we actually built our own custom classifier here that you can see is multilingual. So it's able to apply this to different languages without changing the model itself. It also performs with a high degree of accuracy, sorry about that, where you can actually see that it's able to identify the cursive itself as well with very little error. So you can see here that only the two E's, the L's that look like E's, cause an issue. And one thing about us is that we don't pretend that this technology is going to be perfect right off the bat, which is why we provide these tools for continued augmentation and process improvements. But you can see from handwriting or from even regular fonts, you're able to extract that metadata in real time. Please feel free to ask questions or tell me to slow down or speed up as needed. We also, as I mentioned, provide closed captioning, and the languages listed here along with their dialects. We provide the speech to text and closed captioning, and that allows us to provide the machine translation and subtitling. All of this is easily trainable and searchable, and these models can actually be augmented, or languages can be added with a fairly relatively lightweight, not a heavy lift to add new languages, depending on the access to data. One last tool that we do provide is real-time video fingerprinting. So this is different from the computer vision in that it's much more lightweight. It runs on CPUs. It runs in real time. It can scale up to hundreds, if not thousands, of outlets. We track currently 150 outlets worldwide, doing advanced media monitoring for the intelligence community, or tracking anti-piracy claims, royalty claims, and rights management claims. We also look for competitive intelligence and media planning and sales optimization data based on tracking advertisements, based on tracking content across, again, the 150 channels in the US and mostly in the Middle East at the moment, but we're adding channels daily there. And then this is where I'll hand off to Mark to discuss some of the newer technology we have and have been working with Bloomberg and Bloomberg in the Middle East as well on this in a multilingual setting. So Mark, go ahead.
Sure. So I suppose at a very high level, what we're building for Bloomberg at the moment is a very kind of fine-grained kind of ultra kind of laser focused recommendation or personalization system. So Bloomberg, ultimately what they're looking for is the kind of younger generations today. They're kind of conscious that they're not likely to sit down and watch a news program for 45 minutes or 60 minutes or whatever it might be. So kind of what they're targeting here is very short snippet of video clips. Basically, an entire news broadcast is broke down into 60-second segments, 2-minute segments, whatever it might be. And the idea is that by applying kind of very well targeted personalization, that it's just a better chance that the younger generations will interact with Bloomberg's content, basically. So that's kind of what we're looking at here. And the kind of big differentiator that we have from typical, I mean, personalization recommendations been around for 20, 25 years. I'm sure Oracle have teams that work on personalization. I'd be surprised if they didn't. Ultimately, the main differentiator is that we're more focused on recommendation or personalization through understanding the content itself. So by using all these kind of tools and technologies that Amro talked about, better than anybody in the market, I would guess, including the main players, including Amazon and the other big players in personalization, we can actually understand the news content at a very detailed level. So we can understand exactly what the story is about, who's been talked about, who the key people within the story are, what the teams are, where the locations mentioned were, if it's a video clip, what's been shown within the video clip, who's actually talking, who's been interviewed, what did they say, who was quoted, and so on. So we're pulling all of this information out of the content, and by actually using that kind of understanding of exactly what it's about, it allows us to understand at a very, very detailed level users' personal preferences. So as users use the system over time, we can align very, very detailed, fine-grained interests to those users. So in a typical recommendation system, like is used widely at Amazon or Netflix or any of the big companies, let's say, they use an approach called collaborative filtering. And basically, collaborative filtering is the idea at a very high, simplified level, the idea that if we can find people that click the same items by recommending items that somebody with similar clicks had viewed that you hadn't, that's a good recommendation to make. And generally that works well, but it's not laser focused enough for the use case that Bloomberg has. So that's the kind of big differentiator in this space. And one of the things that we're actively looking at the moment with a couple of media agencies in the Middle East as well is how you can then take this information and use it for advertising purposes. So if you can understand users' interests almost as well as the big social media firms like Facebook and so on, like you have so much information about very fine-grained details about what people are actually interested in, what they're not interested in, and so on. It should be possible to actually better monetize, better help publishing houses across the world monetize their content. So print media is really struggling with monetization. They haven't really found a way to make it work. A lot of them have moved over the paywalls and so on. There's issues with that. You tend to lose about 90% of your readership by moving to a paywall from recent research. So this is the type of problem that we're trying to solve to them with this system. I'm not sure if I've explained that well or that made any sense at all, but if there's any questions, fire away. Maybe the next slide, Amro. Perfect. This is just, so again, because we've been working on a lot of video type technology, this is just a project that came across with a customer about 12 months ago. So basically we developed a whole kind of suite of capabilities to detect items that might not be suitable for certain audiences, let's say, particularly within the Middle East region. So a lot of our customers are media and content producers within the Middle East, and certain stuff is kind of sensitive to show at certain hours of the day and so on. You don't want to show children stuff that might not be suitable for them, etc. So we've developed a kind of suite of technologies that first of all looks at speech content. If somebody's speaking within a video clip, we try and recognize if that speech is one of these kind of red flag issues that's of interest to these companies. So for example, is there bad language within the speech? Is there language that might be construed as offensive or racist? Is there language that potentially might be sensitive? Is there language that we've even trained a system actually to recognize potential language that might be suicidal in nature, or might be a big kind of mental health red flag, for example. So we've kind of got this suite of text-based classifiers that can pull up anytime this type of language is specified within a video clip, within an audio clip, and the system can flag it basically. In addition to that, then we've done visual classifiers in this space. So ultimately, they want to recognize things like nudity. Nudity is a big one. Certain areas of the world have more lenient laws, let's say, in terms of showing nudity on the television. Certain areas are more strict. So within this nudity detector that we have, it can actually detect very subtle nudity all the way up to kind of hardcore nudity, for want of a better phrase maybe. So there's actually a scoring system in it that allows a customer to specify, this is the level that's acceptable to me, and once it goes past that level, alert me, let's say. Some of the other stuff that we've done is more around violence detection and extremist detection. So in this space, we work a bit with the US government in terms of trying to detect when an extremist clip might be shown on the television, for example. So as Amro said, we're monitoring well over 100 television stations around the world, and at any point in time, we're accurately tracking extremist content, where it shows, what stations it played on, what regions are accessible for that type of content, and so on. So that's kind of what we do in this kind of compliance area. Maybe the next slide, Amro.
Yes, so just to add to Mark, so this is actually a use case that we've seen from many content owners and content distributors that has been kind of uniform, and they're really struggling to find a solution that balances the massive workforce they have already and they're striving for automation initiatives as well. So this is something to further explore as well. So this kind of talks about a real use case, again, going back to RAI, where whether we're dealing with live streaming or content that's going into the archive, it's ingested into the classifiers that they're interested in, which is around 5 different engines running on the Oracle Cloud, as well as actually it's going to start by running on-premise. That is then sent to OCI streaming for the Kafka queue, which allows for them to pull the specific metadata that they're interested in around events in content. We also pass that data down to the ADW, where it's tied into the viewership data. And then the process and integration cloud allows the analytics to really showcase what viewers are interested in and what they're tuning in for, and what they're tuning in, what they're leaving the broadcast for because of. So it allows you to create content that's more intelligent, more engaging, and distribute it on different mediums outside of just the linear stream. As we see, that's a big adaptation that the media industry is going to have to face, seeing as how a lot of these events are now delayed or different. They're going to have to rely on connected TV, VOD, streaming VOD, and the OTT broadcasts, and they've been struggling to monetize around that. So adding this extra layer of data and analytics allows for that customization, targeting, and hyper-personalization. So this is just an example of some of the architecture we put together for a hybrid solution, where it would run on-prem on the client's data center, but it would also connect to two sites and provide redundancy as well. We can dive into this a little bit deeper if anyone's interested offline as well, and specific to kind of the media industry, but also applicable to various other industries as well. So kind of moving forward, we actually are partnered with SailGP to track in real time brands and logo occurrences. Previously, it had taken 4 weeks to get a simple CSV file, and that CSV file was literally said Rolex 8 minutes and provided no other information, or Oracle 10 minutes and provided no other information. What we've been able to do in working with the Oracle EMEA Cloud Pursuit team is be able to say, okay, this is the logo that's present. It's present on this boat, and this is how long it's been present for, allowing them to have sales intelligence tools, but also allowing them to advertise their inventory at a premium, because this data is not readily available to the brands and sponsors and agencies that actually sell and buy and pay for this data. or pay for this access. And you can see this is quite a violent environment with boats going at 70 knots. And again, we do not pretend to be perfect. This is an earlier version, but you can see here the UK flag is within the Australian flag. There's not much you can do about that, but in combination with the analytics platform, we can actually weed out this data and show the most actionable data. Another point to kind of bring up is demonstrating using basically software and computer vision technology, whether this is the best and optimal location for a brand and sponsorship placement, or whether it should be up here, or whether it should be down here, or on this side of the hole. So it allows them to actually, we're working towards calculating where the optimal placement will be to empower their sales team to then go out and bring these brand sponsorships back. We think this will be very important as we progress into the rest of this year, as people are kind of rethinking how important their television broadcasts and streaming broadcasts are going to be, and how important the tying this unstructured data and analytics with the structured data is going to be for them to retain these sales and not lose something in the neighborhood. I think 19 billion is currently on pause with sponsorship data and sponsorship spend. But you can see here the actual race that we were able to do this year. We have a analytics cloud instance running, and again, I'd be happy to take a deeper dive with anyone offline who's interested in this. And of course, this isn't limited to just sailing. It can be, for example, someone we were working with a Formula One account, and they gave us 10 different logos and said, hey, can you track these? So this is the output. You can see Johnny Walker's tracked, DHL's tracked, but even Shell on the car is tracked as well. This is more for the broader overview rather than the actual very zoomed in on the vehicle. Of course, both can be done. And of course, as we move into different sports, thinking about soccer and football moving globally, this provides a real advantage for different leagues to promote, basically a system that's going to provide them with actionable intelligence to their customers, to their end users. So essentially, to talk more about the process, step one is the computer vision. We process the videos and identify the KPIs based on the customer requirements. So as I mentioned, that would be for SailGP, that would be the who, what, where, and when. Then the process and integration cloud queries the media type of interest and writes it to the database. This is an example of something Chris Pietor was able to put together for us, and kind of helps visualize how the process works. So you can see here, it detects the logo, and it's able to basically also alert the user to an event, and then provide those analytics at the end of the real-time event as well. So they can check in real time. They can query exactly what they'd like to see, and then they can actually or automate that process and have their queries preset and have the most actionable information presented to them in real time, as well as looking at it in a historical dashboard view. And of course, as I mentioned, analysis. So looking at the different intervals, and providing geospatial metadata as well. So not only that it appeared, but using the bounding boxes and the coordinates x1, x2, y1, y2, we're able to provide where it appeared as well. So this provides an extra set of granular metadata that can be drilled down to analyze what's the best size, what's the best location, as I mentioned. And this is really all self-service and provides really good ease of use and a really good use case to take to other leagues and other sports as well. So here's just a kind of an overview, a high-level overview. So as I mentioned, the models run on the OCI. It's queried to the ADW. And then we store some images and some video of the bounding boxes, of course, as a sales tool, mostly as a demonstration tool and an accuracy checking tool. But really it's the JSON and APIs that really provide the analytical data that's very actionable here. and then the reports go to the client and are used as needed on internally and externally. So moving forward, and if there aren't any questions, sorry, we're moving kind of quickly, want to make sure, conscious of time. Moving into smart city applications where we're applying real-time video analytics for a variety of reasons. But we'll start with retail and security video analytics. So despite what's happening now, as we return to the new normal, quote unquote, a lot of people are looking to understand and basically optimize their visits to retail locations. And what we see here is the advantage of our technology, and using the blurring technology that we use for the nudity detection, which can process in real time and comply with GDPR, of course. We're able to show, the gender, the demographic data, the age of the users themselves. Sorry, apologies for that. And what you can do with that data is not only track where the users are spending time, how much time they're spending, but once you tie it with the point of sale data, so once you tie it with the receipts for that day, for example, the total footfall, the gross sales, peak visitations and times, so you can optimally staff, where people are spending time, what type of people are spending time where, and what are they looking at based on the layout of the store itself. This isn't exclusive to indoor. This can also be used to monitor outdoor locations as well. So whether it's a town square, a beach, or even a billboard, looking at and counting the different objects that pass to generate impressions on fixed instruments, on fixed advertisements, provides the intelligence that's really needed to create that customized experience. And then moving into the security side, we have activity recognition that can be trained. We identify the weapons as mentioned. And of course, we have customized alerts based on just basic human logic that will alert to perimeter breaches, alert to congestion issues, and things of that nature. And that's kind of where I'll turn it over to Mark, where he can kind of explain the uniqueness of the methods that we're taking.
Sure. So I think some of the kind of differentiators that we have in this space. So like person detection is not a new technology. It's generally worked pretty well for 5, 6, 7 years now. A couple of the kind of technical additions that we've made to this is very, very accurate person tracking within crowds. So for example, once we detect somebody, we can track them throughout a scene based on their appearance, effectively, what they look like. So this helps a lot with security use cases. Like, for example, if a security office is looking for somebody and says, okay, that's the person I'm interested in, where did they go? And in addition to that, we've also come up with these, what you see on the screen at the moment, which we call person attribute extraction. So there are issues with using facial recognition in some jurisdictions. Also, frequently with security use cases, facial recognition might not be applicable due to camera angles or distance from the camera or the size of the face within a frame and so on. So to kind of counteract this and still make it possible to track persons of interest, for example, we extract all of these sets of attributes that describe the person in detail. So for example, a security analyst could say, okay, I'm looking for a male in a yellow t-shirt, a pair of blue shorts, carrying a backpack with a child, for example. Can you find them for me across these multiple scenes, for example? So this kind of gets around a lot of the customers or potential customers that we've talked to in this space. They're very nervous about facial recognition. They're nervous about the legal ramifications, and it's an area that they just don't want to get involved in. So this is kind of a nice solution that still solves a problem for them without them going down this kind of legal quagmire, let's say. In addition to some of this stuff, like Amro said, I don't know if you want to zoom back out, Amro, maybe. We've also, so this is something that we're actually working on Oracle with, a team in Oracle based out of London, which is, it's to do with tracking crowds, primarily things like queue analytics. So if you have areas, I think we're targeting very large public events, for example. If you have areas, can you tell, well, first of all, is there a dangerous element like overcrowding, for example? So I think Amro might have showed it quickly on the screen there. We can, within this, we've kind of calculated a way to turn this two-dimensional video into a three-dimensional scene and work out how many people per square meter per certain region within a frame and within a 3D environment, for example, exists. And once that passes a threshold, an alarm can go. So you can think of this being used in places like football, soccer stadiums, large outdoor events, and so on. In addition to that, the same technology is then used to actually provide detailed analytics on queues within businesses or large public areas. So for example, if the customer specifies that this is the region here where people queue, the system can generate, okay, well, first of all, is there a larger than expected? Is there an outlier queue size at any point of the day? It can be alerted, but then also provide analytics such as these are the busy times, this is the type of information that's useful to you, so that maybe you can upstaff in this area or downscale in this other area and so on. So it's some of the kind of types of use cases that we're working on in this space. But as I said, a lot of what we're doing in this specific area, these kind of large event detections, is with the team in Oracle already. I'm not sure if there's any questions on any of that or anything. This is again one of the other use cases within the space. We have a very, very accurate facial recognition system. From benchmarks that we do within this space, generally a human is expected to get around the 97.5% accuracy when trying to recognize people on CCTV screens, video screens, and so on. And the system that we have is the current accuracy is about 99.6 on the main benchmark. So it's significantly better than human experts within the space. So some of the use cases that are common for using facial recognition are things like trying to detect what we call blacklisted persons. So we can think of if somebody is a well-known criminal or somebody has tried to access an area that they shouldn't in the past or something like that. In real time, they can be added to this blacklist, and the system can alert the analyst or whoever it might be if this person is detected within a specific area, and that's all kind of configurable within the system as well. I'm not sure, again, if there's any questions on that. Cool.
And so kind of just touching on that and moving into applied use cases in CCTV, this showcases kind of the activity of shooting an explosion. This is the Gen 1 UI that we mentioned. We have a new user interface that's much smoother and nicer here. But you can see here it's allowing you to search the insights of this specific video, but also you can search globally here. And then you can jump to specific points in the video that might indicate specific interests, such as an explosion, and then identify more metadata from that explosion, such as time, how many people were affected, potential injuries, and then help dispatch and be proactive rather than reactive. We also in our models we train in distortion, so we realize that no use case is ever usually exactly how we want it. We don't expect the video to always be the highest quality. But as Mark mentioned, not only tracking that this is, a car or a person or, even the attributes, but being able to recognize what color attributes and being able to identify a person on a motorbike or a white truck or a red car from very low resolution footage. And this isn't that low resolution, but there is much lower out there. And being able to do this across, multiple live streams and different CCTV camera networks at once. And you can see here, I'm jumping to a different stream here to demonstrate that we do train distortion into the system to allow it to perform better in real life environments. And we've learned this in our work with the Defense Department and in security use cases. And you can see here it's accurately and consistently recognizing the right objects in a blizzard. Which tends to kind of fry other systems as well. So really the key takeaway here is that we're able to, our models are already built to handle distortion, but we can also train in any noise that we might see in use cases with the customer fairly quickly without too much of a heavy lift. And then lastly, as Mark mentioned, creating these unique alerts. So you can see here, alerts are generated based on the user's preference. So here, they're looking to understand if anyone falls into the platform. And you can see here, as soon as this person's head crosses that threshold, an alert is sent. And that includes an email with the video, as well as a thumbnail that can go through SMS or via the process integration cloud, can go through various outlets or even contact the authorities directly. So it allows you to customize the alerts and automate a lot of processes that might have been manual to begin with. This kind of dives deeper into the consumer attribute evaluation without facial analysis, which, as Mark mentioned, is important because many people are not interested in even flirting with the privacy issues. And now that we're moving into kind of the post-COVID world where everyone will be wearing masks, at least for the foreseeable future, we think this feature actually provides a lot of contextual metadata that can be very, very helpful into providing either a secure environment or a consumer behavioral information that allows them to tailor the experience and provide a more customer-driven experience as well. But also in the security case, you can track an individual without needing to have discerning features or identifying features from their face. So just looking at their clothing and their profile and creating kind of a video fingerprint, for lack of a better word, or a fingerprint of that individual and tracking them across camera networks. So as Mark mentioned, we do have this in action. So we just completed a 14-week pilot with CIMB, one of the larger banks in the ASEAN region. So that excludes mainland China. And they're interested in person counting, tracking the duration of individuals, and things of that nature. So this is just a demonstration of the capabilities and the density while maintaining accuracy, as Mark mentioned, without extracting anything that's going to be violation of GDPR. And what we're able to do in doing so, even at 1 frame per second and a very, very low resolution, so thumbnail resolution and 1 frame per second, we were still able to create and extract extremely valuable metadata. So how many individuals entered this branch in a week, where they spent their time. So the majority spent their time in the waiting area. In the waiting area, there are marketing materials. So tying the marketing materials that are being presented with the promotions, the promotion itself, and if it was actually, basically used by the consumer, allows them to also measure the effectiveness of their marketing. So not only are they analyzing where people are spending time, where they're moving to after. So you can see here, not only are we looking at where they spent time, but where they entered, and then where they spent their time. So at branch reception, waiting area 1, then moving to a teller, or moving to a meeting room, or moving to a ATM. So it allows you to really track the consumer experience and track individuals across, either a closed or even open air, experience or location. So whether it's a beach and tracking density of crowds, or if it's at a bank to ensure social distancing is enforced, or just tracking us to understand where your consumers are spending time and optimizing your staff to reduce cost or to increase the effectiveness and experience of the visit to the brand's location. So this can be deployed on a micro level, as you saw, but also on a macro level, where they can see the various branches' performances. So currently we actually use some of the person re-identification attributes to eliminate employees from this count and eliminate false positives from this count. So you can see here, the example that I like to use is, employees might go out in and out for smoke breaks, thus, creating an illusion of the entry and entrance tripwire analytics right now to measure footfall. And it might say a branch that is very much underperforming has a huge amount of traffic, when in reality, all that traffic is created by the employees. So we're able to filter out that content and show, changes over time at a micro level to various locations, or specifically drill down to a specific use case. And this was presented to the Supreme Committee in Qatar for the FIFA World Cup 2022, not only to discuss the customer experience and CX side of things, but also to be able to provide analytics on the type of people, where they're spending their time, their demographic information, and extracting that, and then being able to basically create these visualizations intelligently and easily, even from a mobile phone. So you can see here that you can type in, the stadium, the count. So that's what they're interested in. And then, of course, you can assign time, and then you can extract different demographics and create different visualizations. But the idea is that it provides this actionable intelligence in real time without too much of a heavy lift or change in or adding hardware or adding anything else. So it really provides a tool that is almost an end-to-end solution without too much disruption at all, without any disruption really at all. And then, of course, you can choose and plan and schedule the frequency and understand exactly what's happening when. So that kind of is just a brief demo that we've done there, and we're still in conversations there. Obviously, it's 2 years away, so there's a lot of pressing issues with the COVID side of things. But you can see here, in combinations or solutions, kind of create this very, very powerful ease of use and very powerful capabilities. And then lastly, as we finish up, discussing, moving forward into facilitating the new normal. So we know that every government is, struggling with managing the privacy versus risk mitigation aspects of this. So we've actually partnered with another Oracle partner to work on touchless temperature readings from 3 meters to up to 30 meters with high accuracy. We also have developed a classifier in less than a week that can actually measure social distancing accurately. So it shows the cluster of the family unit, and it will notify you if there's a violation of the social distancing there where you saw the red. So this can also be applied, and the other technologies that we've built on, as you can see, to also do trace interactions. So imagine a large corporation, and they discover one person is positive. They can then trace the interactions of that individual using computer vision from their CCTV and security infrastructure as it is. And lastly, we're working with a sensor manufacturer that can zoom from 8 kilometers away and this, we think, this use case will allow for municipalities, local authorities, all the way to federal governments to provide decision support and risk analysis tools to the users themselves by simply providing these video analytics and data. And lastly, we're working to combine the voice and vision aspects for touchless access. So using a basic smartphone camera and microphone, we want to introduce voice and visual biometrics to allow for touchless entry, whether it's to an apartment building, to a stadium, to a corporate headquarters, or even a satellite office or data center. So that's really where we are now. And thank you for joining us. And we appreciate your time and really excited to share any further information. If anyone is interested specifically on the public safety and security side of things, we also have some interesting use cases that we can share on aerial reconnaissance and aerial metadata extraction from aerial video and UAVs. But thank you for joining us, and please let us know if you have any questions. I'd be happy to answer them.
Yeah, so we received a few questions on Slack, so I'm going to read them now. The first one's from Ilan. Is it possible to extract a quote from someone in a video?
Mark, do you want to talk about the quote extraction that we're doing now?
Sure. Yeah. So it's not production ready at the moment, but it's something that we're actively working on. So we expect to have this. Basically, we're using a combination of speech recognition with facial recognition, and also a small bit of activity recognition to detect who's the speaker on screen and so on. It works reasonably well in kind of experimental settings, let's say, but it still needs a small bit of work before we could put it over to production. So I would expect that to be up and running in the next probably 4 to 6 weeks. I would expect that type of thing to be available if there's a good use case.
Okay, thanks. So another question from Bernard. Do you have use cases on judiciary? It's a very common requirement here to handle video and audio depositions.
Yes, we actually do. We actually are, we work with a few of the 3-letter agencies here in the US, and we actually have a combination of hardware, software there, where it can actually be an appliance that we send to the actual, agency itself, who then can basically set the wide array microphone, do speaker identification and highly accurate transcriptions for the interview setting, as well as, monitor for specific activities or monitor for alarming, alerts or anomaly detection as well, using the existing infrastructure they have in place.
Okay. Another question from Tuan. Can you combine multiple models, facial, emotion, logo, etc., to determine a score, positive video / news conference versus negative PR?
Yes, we can. Yeah, go ahead, Mark.
Sorry. No, go on, Amaria.
So yes, everything we do runs in a multimodal kind of approach. So yes, you can layer the speech, the image classifiers, and even the machine translation as well. And you can identify specific events, specific topics, specific images. And yes, they do run concurrently and provide basically layered metadata that then can be filtered using either the APIs or even something as simple as the CSV export if needed. And Mark, if you have something to add, feel free to.
Yeah, so it's not something that we've done specifically, but all the components are there to be able to do that type of use case. So it's like we have all the metadata available from all those classifiers. So in theory, yes, it would be very straightforward to actually say that's a very positive aspect of the video clip and that's a very negative region of the video clip. And some of the other stuff, we have a sister company actually that does some work in even analyzing the speech itself and determining sentiment from the speech, not just from the content of the speech, but the way that the speaker actually the way that like how aggressively they speak or whatever it might be. So like all of those types of technologies could be used in tandem in a pretty straightforward fashion to do exactly that use case.
And we are working on extracting emotion from speech as well. That's actually in the process of being trained in a multilingual environment. So not only just addressing one language, but multiple languages concurrently.
Cool. So next question from Ilan. Does the automated compliance detection generates a new version of the asset or it just add a new layer?
So that really depends on the use case of the customer. So we spoke with Charter, a large cable company here in the US, and they wanted it simply to be flagged and they'd manually review it. We worked with another company called Ubiquity who does 720,000 hours of video distribution a month globally, and they wanted it automated because of all the different regions, all of the different rules and parameters and standards and practices from all these different sites and countries. So they wanted to look at a more automated way of doing it. So it depends on the customer use case, but really what we prefer is to automate 80% and provide a reduction in workforce that's going to be a huge cost savings, but also keep a human in the loop so it's not eliminating an entire workforce. It's a much easier entry point that way.
Okay, next question from Tuan again. When the AI engine detects certain compliance of interest, can an automation process invoke a notification to interested party, called third party, Oracle SaaS or PaaS, etc., interested in what APIs is available to integrated with other systems applications?
Yes, so absolutely. So that was one of our goals in designing the system, is to be easily integrated. Either we can bring in APIs from other solutions, or we can pass our APIs to be integrated into other solutions. So yes, that's something that we can do, and it can be automated as well. And this is specifically very important in the security use cases and the real-time use cases where this proactive information is needed in real time.
Okay. Another question from Tuan. How can you retain the model? For example, the wrong detection of the flag, logo, facial, voice, emotional detection, etc.
How can we retrain the model?
Yes.
Okay, so Mark, if you want to go ahead.
Sure. Apologies, Amber. I have to actually jump to another call, but I'll quickly just answer this before I go. I'm already a bit late, but so ultimately we use an approach that's called transfer learning. So we take an existing model that's been trained, and we take the feedback from an annotator, let's say, or from a system analyst or whatever it might be. Like, so for example, if a system's live and somebody says that's made a mistake, such as in the case with the UK flag, that can then go back into the system and it's trained on top of the previous model. So ultimately, as feedback comes back into the system, those mistakes won't happen again. So the model kind of learns on the fly as it goes along. So every time a mistake is shown to the model, it's unlikely that a mistake or a similar mistake like that would be made in the future. I'm not sure if that answers that question or not, does it?
Yeah, it did answer the question. Thank you.
Okay, perfect. Apologies, guys. I really have to jump. It was a pleasure talking to you. I'm sure Amro can stay on, but yeah, any questions or anything like that, feel free to reach out. It's no problem.
Thanks, Mark.
Yeah,
Thanks,
thanks a
Mark.
million, guys. Cheers. Bye-bye.
Cheers. And the last question is also from Tuan. Great example of integration with Oracle OIC and ADW. Is there a write-up of the use case?
Yes, we're working on that. We're going to start in June, as some of the folks on the partner side with SailGP have actually been furloughed, and they'll be kicking things up in June. So we expect to have a white paper and case study written, hopefully within the next month or so on that. And we actually do have a presentation that dives deeper into that. Actually, Chris Pieter was very helpful in creating, that I can share with everyone after the call.
Great. That was the last of the questions. Ilan?
All right. Thanks, Enro, and thank you. You can ask. Thank you, Dr. Mark, for me, Enro, to present us today. You just got a fan. I gotta say, the stuff that you guys built, it's really, there's so much thing, like new Matthew said, there's a bunch of use cases that we can match up, and hopefully you guys will be able to handle all the users and all the customers and everything. But I'm really hoping that you guys catch up. You got great stuff, tightly integrated with Oracle, software, and I think it makes total sense for you to engage in some of the the stuff that we do. I'll do ask for your permission to share your contact, actually, your email or Mark's email in the internal Slack. Is that okay for you guys, so people can reach out?
Reach out at any time, and with any use case. That's actually something that we love to challenge, and we love the challenge of complex problems, and we love to discuss new frontiers. So if there's anything where you see applications here that we may not have covered, it's something we're very interested in pursuing together.
All right, absolutely. So thanks everyone for joining us today, and have a good last week of the fiscal year 20.
Good luck, everybody. Thank you so much for your time. We really appreciate the opportunity to present. And again, please feel free to follow up with any questions or any further requests for information. We're here at your disposal. Thank you, guys.
Absolutely. Bye-bye, guys.
Bye, everyone. Thank you. Take care. Stay safe.